3.
Killer whales are known to reach 32 feet in length and have a mass of over 8 kg. They're also very quick, able to accelerate up to 30 miles per hour in a matter of seconds. This requires a considerable drag of water. Calculate the average power a killer whale named Shamu with mass 8 times 10 to the power 3 kg would need to generate to reach a speed of 12 meters per second in 6 seconds.
Okay, now here they are giving you the units in this system, the British system, 32 feet, 30 mile per hour, right? So you just ignore these numbers. We are not going to use this number in our calculation because we don't know. We don't know the equivalent in the metric system, right? So we just ignore these two. Now we look at this one only. 8,000 kilogram, speed 12 meter per second, and they reach this speed in 6 seconds. So we are going to use these three, only these three. Okay, we are going to use these three because they are SI unit. So we know they are consistent. Whereas these two, they are not compatible. They are the British system. So we don't use this. We use these three numbers, these three values. Okay. So if you want to calculate the power this time, we are not going to use the force multiply with the velocity. We are going to use the work done divided by the time taken. So this is the formula we are going to use for calculating the power. Okay, so how much energy is used when the whale is swimming at 12 meter per second, right? How much energy the whale has to exert in order to swim at 12 meter per second. The mass of the whale is 8,000 kilogram. So we calculate the energy used by the whale by looking at the kinetic energy of the whale. So the kinetic energy of the whale is the initial kinetic energy minus, sorry, the final kinetic energy minus any initial kinetic energy that it has. So if you look at the whale swimming at 12 meter per second, you calculate the kinetic energy. That is the energy used by the whale. But actually, that is not the energy used by the whale because the whale not only has to achieve this velocity, it has also to overcome the friction, the water resistance in order to achieve this velocity. So the question say, okay lah, don't you just disregard the friction, the resistance of the water on the whale. By just looking at the kinetic energy of the whale, you just calculate how much power. But actually the power is more than this because it has to use up energy to overcome the frictional force, the water resistance. Maybe you know better right? Because you are swimmer, so you know better, right? You want to gain the speed, not only you have to achieve the speed, you also need to overcome the water resistance. But then the question said disregard. Okay, so now we just look at the kinetic energy of the whale. Kinetic energy is half mv squared. Initially is 0, so half times 8,000, the mass of the wheel, and the velocity 12 meter per second square. Okay, square, half mv square. So using the kinetic energy, we calculate and we know the total energy used by the wheel to produce this to produce this velocity is 700 and sorry 576,000 joule. 576,000 joule. So this is the energy produced by the wheel. So you want to calculate the power. You use the energy divided by time. So energy is 576,000. Time taken is 6 seconds. So divide by 6. Answer is 96,000 watt or 96 kilowatt. Okay. So this we use the energy divided by time. That is the power. Okay. Any question on this wheel?
No questions, sir.
No question on the wheel. So we're going to look at some enrichment questions. So go a bit further. If the wheel could double his velocity in double the time, by what factor would the average power requirement change? The question is, now they say the velocity is double. Instead of v, they have 2v, the velocity. Then the time is also double. Instead of t, they have 2t. The time is also double. So in order to produce this type of motion, how much has the wheel to increase its power? Increase by 4 times, increase the power by 8 times? Don't know. But you see, actually, although the velocity increased, but the time taken is longer, so the wheel doesn't need to work so hard. You take a longer time to achieve this velocity. So how are they going to balance out one another? So in the end, how much will the change in energy and how much will be the change in the power? So in order to calculate the change in power, we try to calculate the change in energy first. By what factor? Okay. So the kinetic energy of the wheel is half mv squared. The kinetic energy of the wheel is half mv squared. Now this is the first case. This is the first case in this question here, right? This is the first case. But in the second case, the velocity is double. So we can no longer use v here. So half m, instead of using v, we use 2v because the velocity double. So when you square the 2v, it becomes 4. So that means if you want to double the speed, the energy has to be 4 times. The speed double, the energy has to be 4 times because the energy is v square. 2v square become 4 times. So energy 4 times, never mind. But that is not what they want. They want how much is the change in the power. How much is the change in the power? Okay. So we know in the first case, the power is the energy divided by time. Okay. Energy is half mv squared. Half mv squared divided by the time t. Divided by the time t. And it becomes mv squared over 2t. This is in the first case here, right? mv squared over 2t. In the second case, we still use the energy divided by time. Oh, this is very big. Make it smaller. Too small. Okay, this one. So the power is the energy the energy divided by time. Divided by time. Now this energy is actually 4 times. In the second case, it has become 4 times. So it has become 4 times. 4 times. Okay, the energy used is 4 times. And the time taken is double 2 times. So the 2 times. So 4 divided by 2, 4 divided by 2 is 2. Right? So the power need to double. You need to double the power. You don't need to 4 times the power. Right? Need to double the power. So we look at the calculation here. This is the energy, right? 4 times half mv squared. Now this is the time taken, 2t. So the 4 divided by 2. 4 divided by 2 is 2. The other one is the same, mv squared over 2t. This one also mv squared over 2t. So we know that the power has to be double. The whale needs to double its power to achieve this. So we are actually using this formula. Power is the energy or the work done divided by time. So instead of using a wheel